What causes switch containment failure? Switches are supposed to only forward stuff with a particular destination MAC address to the port that it belongs on. A few circumstances where this breaks down. Certainly software and hardware failures cause that, which are more or less common depending on how reputable your switch vendor are. Cheap switches, the kind of thing that you would buy in Micro Center or Fry's or somewhere like that to connect your home kit to. These generally are not designed for industrial strength. They'll have a limited content addressable memory table size. If you actually introduce traffic into that switch that's too many source addresses, it fills the CAM up. What does the switch do in that? It just reverts to being a hub and it forwards all traffic to all ports. So you've lost the security of being a switch. Best way to avoid this is don't use cheap and nasty switches for internet exchanges. If the switch vendor also happens to sell cables and washing machines and DSL routers and stuff like that, then probably you don't want to buy one. You probably want to buy it from someone whose business is like doing switch manufacture, router manufacture. The better ones don't just do the MAC switching destination port right. They can also do things like only limit the number of MAC addresses per port to a specific number or to do other kinds of filtering. Problem broadcast traffic. As I say, really the only broadcast traffic you need, the only thing you connect an internet exchange is a router. If you get a router connected, the only thing that you only need to broadcast stuff between these routers is ARP. If there's anything other than ARP, if there's more than a few ARP packets per second, that is abnormal condition. If you don't do something about it, something bad's going to happen eventually. Likewise, there shouldn't be any layer 3 IP broadcast traffic. I mean, that is wide open to Smurf attacks anyway. But there's a whole bunch of protocols like DHCP, SMB, BIOS, internal gateway protocol, internal routing protocols, device discovery. Again, it shouldn't be there. ARP is a protocol where there's spoofing abuse possible. Some IXPs actually insist on hardwiring the ARP to IP address mapping. Others use more advanced filtering techniques, depending on how much clue the vendor managed to absorb over the past years of this kind of stuff. You can't always trust an ISP, to be honest, when it comes to interacting with other ISPs. There's some bad guys out there. I hope there are less bad guys than there used to be, but sometimes exchanges have had to do stuff to check out ISPs or spammers, for example. But default dumping, I'm just going to dump all my traffic on this other guy across the exchange. He's not going to know about it, but I'm going to get free outbound traffic. Or you can do that for particular destinations. Maybe there's somebody who's here with you, but you really need to get to one of their sites. NICSTOP spoofing, BGP advertises a NICTOP destination address. You can change what that NICTOP is, and that can cause some curious things as well. The worst abuse case that I had to deal with was this dodgy ISP operating out of London who basically connected to our exchange, connected to one of the big exchanges in the US, set up some static tunnels, and was basically had a website that said, oh, we are a major international transatlantic infrastructure player, and actually they didn't. They were ripping off 3 other people's bandwidth. So that was an interesting exercise that resulted in their kit being seized by Scotland Yard, and I don't ever want to experience dealing with that kind of thing again. Other kinds of routing abuse are much harder. Most BGP sessions are MD5 protected these days. So, okay, there's lots of stuff that can go wrong. How do you prevent and detect that? I think it's very important to have a clear policy for what is and is not acceptable practice. People know what the rules are. There's a whole bunch of documents out there. There's a couple I've been involved in writing, the URLs there. But it's not just about having a clear policy. It's also about monitoring that that policy is complied with and enforcing it when it doesn't happen. There's custom software called IXPWatch being written, which just sits and looks at all the broadcast traffic in Exchange and use that to figure out whether things are working properly, whether there's strange stuff going on. You can use Armon to actually look at the packets on the wire. NetFlow and SFlow that actually tell how much traffic is being exchanged between a pair of destinations or between a pair of ports can be very useful for picking up strange stuff. In general, routers that are dedicated boxes are much easier to secure than connecting a general purpose server. Once you get to a general purpose server, that box gets owned, then there's all kinds of things that you can get up to with it that would disrupt the exchange. That's not to say you can't do evil stuff with routers that are on dedicated boxes, but in general it's harder. Some exchanges actually have rules that say you cannot connect general And again, a lot of these accidents are prevented if you smart of the switch filter high speed. Okay, I wanted to talk a bit about regional internet exchanges. These are more challenging. Once you've established a need for a large exchange and built up critical mass, then all you have to do is cope with the 90 gorilla of traffic growth. You want to set up a regional exchange, it can be more difficult. My experience, one of the single biggest problems is that most of the eyeballs, the people in the DSL connect, cable connect in any given metro area, are locked into 2 or 3 MABELs or cable operators. Generally, they will do their peering, their exchange connection centrally, somewhere over on the west or the east coast or Chicago or somewhere like that. And there won't be either the people with the administrative decision-making power or the technical clue in the local organization to necessarily connect up to an exchange within a given city or metro area. Sometimes there's issues with the infrastructure in terms of finding a site that's both neutral and both quality. Maybe all the data centers are owned by the ISP itself, or maybe the common facilities aren't up to industrial strength standard. Sometimes there will be a lack of competition in the market, and actually buying local books at sufficient capacity from the local ISP spot to the city's internet exchange will be expensive, and that can create a barrier. Making sure there's enough technical clue to go around. I mean, it's not hard, but there is an education process quite often needed there. BGP 101. Sometimes the entry-level technical resources can be an issue. That's more of an issue in developing countries. It's very much less. As I say, you can pick up all the kit you need off eBay these days for a few $100. It's much less of a problem than it used to be. Political interference. I have come across local politicians who, as I say, see the internet exchange as a way of forwarding their career and looking high tech, and actually they do very little in terms of the real getting the traffic on the wire that's necessary. But one of the biggest challenges, and one that's caused failures, cost of transit. In many ways, it's a good thing, but since Y2K, the cost of buying wholesale transit has dropped from hundreds of dollars per meg per month to less than 10. You have to shop around, you have to buy in bulk, you can get internet transit for less than 10 bucks a meg a month. The whole of the code is consolidation and commoditization. What that means is that money you can save from peering is less than it used to be. 20% of your traffic can be saved by peering. 20% 10 bucks is a whole lot less than 20% of several hundred bucks. But there's a fixed cost associated with connecting to an exchange. So these days there's less money to do it. The large IXPs, obviously you've got a volume of traffic there that you have the critical mass to survive. But if you're a regional player, the second exchange in the city, that can make life a lot harder. I mean, unfortunately last year there was an exchange in Cape Town, the main South African exchange in Johannesburg. The one in Cape Town was non-profit. Hit cash flow problems, had to lay off all its staff. They have to do something similar in Manchester, although I think they're recovering from that now. So there isn't a completely economic case. What are the other benefits? Once you've got this place in the middle, which is where you put your internet infrastructure and it's got high bandwidth and low latency, then there's a lot of incentive. It's a good place to put resources, things like top-level name servers, secondaries for .com or .uk or .us or whatever. Time servers, we had all that fun at the link in Y2K. We managed to get sponsored for 3 atomic clocks. So we put a 3 atomic clock on the Greenwich Meridian line. So the 0 degree line went through the building, and that was the Greenwich Electronic Time Project, which was fine until the politicians hijacked it. That's another story. You can do things like performance measurement tools, academic research projects, monitoring how the internet performs, how traffic flows across it. These are all good things to put at exchanges. You can enable new applications. You've got high bandwidth, you've got low latency. Always it improves technical coordination knowledge here and get technical different ISPs interacting and learning from each other. You can create a center of expertise for internet technology, local to the region, and it's also good for coordinating security stuff. Generally, you fairly fast human communication center around an exchange to deal with bad guys. Other advantages, you can increase diversity and resilience. Maybe you're an ISP, you can only afford one upstream transit, you connect an internet exchange, maybe do a mutual backup arrangement with another ISP who's got a different upstream. Reducing latency I've already mentioned, but I mean that's particularly important for gaming and multimedia. Getting that delay down, doing real-time stuff. Again, the medium is very efficient, many-to-many medium, which means that multicast applications work very naturally across the exchange, so it's very efficient. Internet Exchange get into the business of doing other Ethernet services. Sometimes there's competition sensitivities there, but you can do point-to-point, point-to-multipoint Ethernet service. But I think the important thing is you're building a stakeholder community. You can quite often use that stakeholder community for other things. Probably you want to ring fence or Chinese wall the trade association activities from the actual running of the exchange, but that can be, again, quite a good way of doing technically clueful lobbying. Other roles for exchanges, you can create a market of buying and selling transit and other services so that you have you can maybe encourage other transit providers, wholesale providers into the region to sell services, whereas if you're selling one at a time, it might not be. If you have a regional academic research non-profit network operator, then it may be a very good way for them to handle their external connectivity and not have lots of ad hoc arrangements. We did some other interesting other stuff in London. Unbundling DSL. You want to resell DSL, the carrier will quite often require you to get a big fat pipe. Maybe you're not a large enough ISP to do that. We actually had ISPs who were big enough to buy their own pipe, ATM pipe from the telco, and then actually resell fractions of that over L2TP tunnels across the exchange fabric. And other things, just acting as a local loop. There are some players like Packet Exchange who are in the business of doing international Ethernet circuits, and they like using it as a local loop so much well they bought the company, but that's again another story. Why do internet exchanges fail? Inability to be reliable or to cope with growth. It's one thing to start, it's another thing to keep this thing going. Making exclusive arrangements. Okay, I'll just try and wrap up. Exclusive arrangements with colo providers who go out of business, that's what screwed up the exchange in Edinburgh. Not building critical mass. I'll skip over this stuff. Summary. Building an internet exchange is not hard. Resources are widely available, lots of people have done it. There are some cost benefits, but there are a lot more intangible benefits. The hard part are building the critical mass, keeping it viable, coping with growth and abuse. But it's all about sharing with others. That's my experience, always educational and fun. Maybe someday every city will have internet. Anyway, there's my contact details. You can get a copy of the presentation and pack up on these few slides that I had to skip over. I hope that was useful or interesting. Happy to take any questions. One question back there. No, I connect to an exchange. In Cleveland? Not to my knowledge, no. I mean, I don't think that's an initiative that's been done. I know that there was an initiative in Dayton called the DMIC, but I don't know what's happened about that. As far as I'm aware, there's an exchange in Columbus. I think there's another one in Cincinnati, and then there's the one in Pittsburgh that I mentioned as well. So yeah, I don't know. Maybe Cleveland could do this on internet. Yeah. These were kind of abstract diagrams. In general, the topology that most internet exchanges will do is some kind of ring. You can either run, you can try running spanning tree around that, and as I say, that comes with some health warning. Or there are various proprietary technologies for, marking down one link in the ring, and then if it breaks. But in general, you'll have a core, which is probably a ring. Maybe you have two spurs off that for satellite side.